Hello everyone, myself Professor Kishan, Assistant Professor, Department of Mechanical Engineering, Maharada Institute of Technology, Mysore. Today I am here to deliver a session on insight into future mobility technology. Let us try to understand what do you mean by the phrase insight into future mobility technology. See, the word insight refers to the detailed or complete understanding on things or the area wherein the objective is focused accurately. Means to say that to gain an accurate knowledge on something or some area wherein we are focusing, that refers to the word insight. Then the word future mobility technology. It is a common identity for a mechanical engineer to possess his passion towards automobiles. Yes, what do you mean by automobiles? Automobile means it is a carrier which carries the luggage or passengers as well as the luggage and passenger from one place to another place on road. So whenever we are focusing on transportation of human beings and luggages and animals on road through a medium where we opt for vehicles, we categorize that as automobiles. While if it is on water, we go with marine engineering. Whether it is in air, we study the content under aerospace engineering through airplanes. Okay, see, the evolution of automobile engineering is not from 19th or 20th century. It is seen from the 17th century when people started using the mounting of small windmills onto the cartwheels, so that as and when the cartwheels are carrying the passengers from one place to another place, this windmills used to obtain the energy from wind and convert that energy into the motion or the movement through wheels. While this was seen in the earlier 17th century, and later came the steam carriages, or nothing but the evolution of steam engines, which was in the late 17th century and in the 18th century, which even led to the innovation as well as the identification of next level of utilization of the concept engine to give performance to the automobiles, that happened through the internal combustion engines, which happened in the late 18th century as well as the early 19th century itself. While looking at the scarcity of availability of fuel as well as the adaptability wherein people are heading towards the procurement of automobiles for the ease of transportation from one place to another place, there came the necessity of something which is beyond use of fuels, that is nothing but electric vehicles and hybrid vehicles, which came into light when the entire research started going in the 19th century mid as well as in the early of 20th century. Now, why we just discussed about the concept of automobile here is because, see, as a mechanical engineer, we always focus on the concept wherein the automobiles are taken into picture. Okay, so here in this particular topic, future mobility technology, you might have guessed rightly, yes, we are going to study about the electric vehicles and its complete functionality as a source. Before heading into the complete syllabus, let us try to understand certain statistical information related to our own country, India. See, India is identified to be the fourth largest producer of automobiles, where with the average annual production of 4 million motor vehicles is into consideration. India is preferred to be the automobile manufacturing hub because of its low cost of production. The market value of automobile in India is considerably 100 billion US dollars in 2021, while it is expected to be around 160 billion US dollars in 2027, with the compound annual growth rate of 8.1% between 2022 and 2027. Isn't it amazing? Yes, this is where the automobile is pulling the Indian capacities to the global segments. We also have certain other statistical information related to the vehicle population. See, in India, 7.5% of the population owns the four-wheeler, while 55% of the population in India owns the two-wheeler and other commercial segments. The vehicles which are in operation means to say that the vehicles which are legally allowed or permitted to move in India on road is accountability from 1951 is 0.3 million, while the accountability in 2022 is 326.3 million, where this data showcases the amount of automobiles that are available in India towards the expectation or that are meeting the expectation of Indian population. The number of units wherein this particular data relates to why we consider India to be the automobile manufacturing hub, or what it is making India to be the fourth largest producer of automobiles, is because of this reason. See, between April 2021 and March 2022, the number of units, that is number of automobiles which were produced, were 2 crore 30 lakhs 40,066, while in the financial year 2022-23, the number of units got increased to 2 crore 59 lakh 31,867. Means by the visualization we have almost 30 lakh increase in the number of units being produced in India. This is why we are supposed to focus on what is the future for mobility technology. Future mobility technology is nothing but the innovation towards the transportation with lesser amount of emission from the exhaust, as well as the adaptation of the technology leading from electrification of vehicles to autonomous vehicles, which are nothing but driverless vehicles. With this focus, let us try to understand what do you mean by electric vehicles, what are the different types of electrical vehicles, what are the components that contribute for the functionality of electric vehicles, followed by advantages and limitations. See, what is the major difference between IC engines or fuel powered vehicles to that of electric vehicles? In case of fuel powered vehicles, the internal combustion engines use the fuel like petrol and diesel, generates heat, and thereby that heat energy gets converted into mechanical energy, and that mechanical energy is transferred onto the wheels, and that results in the solving the purpose of an automobile. While in case of electric vehicle, the major source is the electric motor that is powered by the battery that results in propulsion of vehicle, that is in movement of passengers and goods from one place to another place, satisfying the demand of an automobile. Here, battery is the main source that provides energy to the electric motor, while the electric motor converts electrical energy into mechanical energy, and this battery can be charged externally, or it can also result in the concept of regenerative braking system. Now let us try to understand different types of electric vehicles. What are the different types of electric vehicles? Basically, we have three categories of electric vehicles, out of which the term hybrid is added, that gives clarity on how the evolution of electric vehicles are there for today. See, the first category of electric vehicle is plug-in type of hybrid electric vehicles. As the name itself suggests, it is hybrid. It is the combination of IC engine and electrical motor powered vehicles, wherein the electrical motor is powered by the battery. The major concept to be remembered here in this particular category is that once we have the number or the name plug-in, the plug-in refers to the external charging capacity being provided for the battery to recharge, thereby it supplies energy to the electrical motor. Now comes the big question, when IC engine and when is the electric motor? It depends on the range at which the vehicles are designed. See, usually the electric or the hybrid vehicles which are of plug-in type are designed such that the initial level of starting the vehicle and to a speed range of up to 60 km per hour or so, it is preferred to take on the battery vehicle, or sometimes it is preferred to take on the fuel type, that is IC engine based propulsion. After getting the energy, then from there onwards, that shift over in the power is achieved based on the performance at which the vehicle is designed and calculated. Similarly, there is a second category, that is battery operated electric vehicle, means the propulsion is achieved through the electric motor, which is supplied with the power only through batteries. Means to say that there is no inclusion of IC engine here. While the third category is only hybrid electric vehicles, and the major difference between the first and the third is that here the external charging facility provided for the vehicle to recharge the battery is not provided. Else, there is a concept called regenerative braking system, which is utilized here in this type of vehicle, that keeps the battery charging whenever the brake is applied. What do you mean by regenerative braking system? See, the concept of regenerative braking is that whenever the vehicle is under motion and once the brakes are applied, the applied brakes result in the loss of kinetic energy, due to which the vehicles are forced to stop. So when the vehicles are being forced to stop, whatever may be the kinetic energy which might be lost while the brake is applied, that kinetic energy is utilized and converted into electrical energy, and that whole concept is called as regenerative braking system. So here, rather than external supply to recharge the batteries are getting charged out of the concept called as regenerative braking system in case of hybrid EVs. So if I am using the word plug-in hybrid EVs, then the vehicle is provided with external supply to recharge the batteries. If we are using only hybrid electric vehicles, that is without the use of plug-in, then we have to understand the vehicle is adapting to regenerative braking system. Now, let us consider the different components that accounts for the complete operation and functionality of electrical vehicle. See, the major constituent of an electric vehicle is the traction battery pack, which stores the energy once it is being charged in the form of DC and supply it at the constant voltage resources to all the components which are available as a part of electric vehicles. So basically, this traction battery pack is the powerhouse that supplies energy to the electric motor, or it supplies electrical energy to the motor that drives the entire wheels and other transmission platform. Next comes DC to DC converter. Why this DC to DC converter? See, whatever might be the power which is available from the battery, the traction battery pack is having the capacity of providing constant voltage DC source. But the components which contributes to the function of electric vehicle need not to have the same amount of power which is required to operate or to function. So in that case, we go with the DC-DC converter, one among the major part of electric vehicle that contributes in distributing the power at the required limits or at the required range. Next comes electric motor, the heart of electric vehicle that supplies electrical energy received from the battery to the wheels in the form of kinetic energy, results in the propulsion of vehicles from one point to another point. Also, if the vehicle is of hybrid EV category, that is, if the vehicle is operating under regenerative braking system to recharge the battery source at that particular point of time, this electric motor acts as a hub to the regenerative braking system as well. This is a very key point to notice. Kindly do remember the concept. Next comes the power inverter. See, the concept of power inverter is that whatever the power which is available from the battery, it has to be converted from DC to AC, while if it is a regenerative braking system platform, there the power is to be converted from AC to DC. For this conversion of DC to AC, while it is being supplied from the battery as well as from AC to DC, if it is a category of regenerative braking system, then the power inverter is the one that functions. Next comes the charger port. Yes, this is the port that connects the EV, that is the electrical vehicle battery, to the external supply. So we generally, whenever we see that, we say that the charging has to be accomplished, then this is the charge port that functions in connecting the entire electrical vehicle battery resources to the external supply and keep recharging the batteries as and when it is required to operate. Next comes onboard charger. So this onboard charger is the charger which is available in the platform or in the system, where it converts the AC source received from the charger to the DC supply, while the DC supply could be transferred onto various components at a required rate by the DC-DC converter, such that the functionality is happening without any deviations or without any delay. You might have seen plenty of accidents that are happening in the EVs nowadays, which are predominantly true. Where does that particular fault starts? One among the major fault that starts with the failure of EVs might be the truly concept of the onboard charger as well as the DC to DC converter. So when there is a delay in operation of these two, this might result in generating shock or variation in the power supply. That might be one among the reason that results in catching up a fire or malfunctioning of electric vehicle. The next point or the next component, controller. The controller of electric vehicle is the power electronics hub that completely take care of the working of electric vehicles. From where? Straight away from supplying the electrical energy from battery to the motor. From the motor, the amount or the voltage source that is to be transferred onto the wheels based on the application of force on the pedal by the driver. That is where this power electronics hub or the controller starts supplying electrical energy to various components based on the speed or based on the power that is to be attained by the vehicle wheel, so that the transportation is accomplished. Next comes the auxiliary batteries. These are the second line batteries which are optional, wherein it operates in the absence of main batteries, while to start providing the supply at the beginning, to initiate the process of electrical supply, or to make sure whenever the main battery is down, these batteries will act as a subsidiary element that keeps the vehicle in operating condition at least for a short period of time or the short distance of travel. Next comes the thermal system. Here it operates with the concept of maintaining the operating temperature. So might be the cooling system, or it might be the air cooling, or the water cooling system, what you might have already known or been aware of in case of IC engines. Yes, similarly here also there is a cooling system that maintains the operating temperature. Why? Because in every phase of its operation in electric vehicles, there is a emission of heat, and that heat will always be accumulating as and when it is accumulated for a period of time. So that increases the overall heat or the temperature of the system. So to maintain that, this thermal system operates with the cooling platform to reduce the operating temperature, to enhance or to exercise more amount of heat liberation while limiting the amount of heat that could build in the system. The last one, transmission. Here, even in EVs, the gearbox are available to transform the amount of energy required from the motor to the wheels based on the application of pedal. But the main advantage is that here in this particular case, you need not to go for any multi-speed transmission units that are available in case of IC engines. So these are the components that formulates or completely take care with the condition at which electric vehicles are supposed to operate. Now, let us go with the understanding of advantages and limitations of electrical vehicles. Whenever we bring about this particular topic, it's always in comparison with the IC engine or fuel-based vehicles. See, the limitations are obviously there, but the advantages do have the predominant effect of having EVs to the market in the coming generation. The first point of advantages goes with lesser in its noise pollution system, where the electric vehicles, you might have observed, cause very less in its noise while it is being made available on road during its transportation. So the second one is eco-friendly during the propulsion. See, when the vehicle, if it is compared with IC engine, if you want to result in maximum amount of power, what we do? We have the statement, right? Drop the gear, disappear. You just bring the gear down from 3 to 2, 2 to 1, okay, so that the transmission system operates in providing maximum amount of power as it is required by the driver or the vehicle to go for its movement from one point to another. While here in EVs, you don't need to worry about bringing down the gear or focus on gearbox or the transmission. The only thing is, as per the pedaling which is being enforced onto the vehicle, that force applied on the pedal result in supply of electrical signals more and more to the from the battery to the motor, so that it is getting transferred onto the wheels. So there is no enforcement on the vehicle during its propulsion by changing the gear or working or giving load onto the transmission. That is where the eco-friendly propulsion comes into picture. Next, less maintenance cost. Keep in mind, in comparison with the engine maintenance cost. See, whenever we have a fuel-based engine, you have to change the engine oil, you have to change the coolant, you have to make sure all the fluid regulatory systems are appropriate. Whereas here, in case of battery, only the life of battery is to be maintained rather than other auxiliary components. Hence, when it comes to maintenance cost, in comparison to engine maintenance, yes, they are less in its expensive. Why? Because of it is only the battery. Next comes the pleasant driving effort with minimum effort. See, most of its kind EVs are available today that makes no noise, that gives you ease of comfort during the propulsion or enhancing the speed. That is where the pleasant driving or comfort is more when it comes to electric vehicles rather than the fuel-based vehicles. And the last one is natural resources saving. Yes, obviously, if we focus it on the fuel-based engines, you have to start from where the derivative is focused, how to disturb the natural resource, and from there how to get the fuel, from fuel how to process it so that we are going to get the energy out of it. So here in case of EV, that is electrical vehicle, you are definitely going to save the natural resources. This doesn't mean there is no limitation. Yes, we have certain limitations. So straight away which strikes your mind, yes, the cost of battery. See, the cost of battery in case of battery vehicle, that is the electric vehicles, is very high. One simple example is that the MG ZS EV accounts about 6 lakh to 8.5 lakhs for the replacement of battery, while the distance accountability for a battery to go with charging and supply of power is approximately 2 to 4 lakh in its miles. Okay, so that is one. Yes, it is very costly compared to that of other maintenance issues that might arise in case of engine or the fuel based vehicles. Along with that, the purchase cost is too high when it comes to electric vehicles. You have plenty of platforms to work on it to make sure the comparison or the on-road price at which the vehicles are available. Do use such platforms and just go for the understanding about the features and the cost in which the EVs are available in market. Predominantly, EVs are really costly than the fuel-based vehicles once it goes with the features as well as the capacities. Next is low speed and range. So this is obviously in comparison to the next limitation, that is the charging station scarcity. See, as on date, yes, it is a limitation. Might be in future we might come across plenty of charging stations with more amount of adaptability to charge the vehicles at a faster rate, so that this limitations which we are discussing today might be the taken off limitations, and we might even add to one of the predominant advantages for EVs to be in the market. So today the charging stations are very less in any number of highways if you want to put it on. So basically, say if you are charging a vehicle, the present EVs are giving you from the range of 260 km to 300 kilometers on an average for a four-wheeler, while for two-wheeler it is in market with 100 to 120 kilometers range. But do we have the enough amount of charging stations? No, it is yet to start. So as on date, as of today, this seems to be one among the limitation, and due to the scarcity of these charging stations, the major limitation, it is low speed and range. The traction at which EVs are available today cannot be considered for the comparison of the fuel-based engines or IC engine vehicles for the amount of propulsion you get, for the amount of torque you obtain during the process of burning the fuel. So that is where the speed in which the EVs can operate is comparatively low to that of fuel-based engines. Might be in future, there might be a competition between these two availabilities in market, and might all these cases of limitations might go off, but as of now, the understanding should be there to the limitations wherein the present trend in electric vehicles are. Now, let us try to understand the concept of hybrid electric vehicles. As we have studied the different types of electric vehicles, if you recall, hybrid electric vehicles falls under a category wherein external supply is not allowed to recharge the battery upon the consumption of energy from the battery. Yes, means to say that the regenerative braking system results in charging the batteries which are available in this type of hybrid electric vehicles, which are powered by IC engines and one or more electric motors. So this is the brief description in which hybrid electric vehicles falls into the category. While if we head into the components that are forming the hybrid electric vehicles, most of the components what we have studied in case of electric vehicles remain same except the charger port as well as onboard charger, because the option of charging the batteries from the external source itself is not made available in this category. Hence, the components that rely on external charging system will not be available in case of hybrid electric vehicles. The major components of hybrid electric vehicles stands with the gas engine or the IC engine, where the engine runs on fuels for generating mechanical output and resulting in transmission of power onto the wheels, while the second component deals with the electric motor, which is the heart of system that transfers electrical energy which is received from the battery into kinetic energy. As well, here in this particular case of hybrid electric vehicles, which operates on a regenerative braking system to recharge the battery, electric motor itself acts as a hub that results in regenerative braking system. While the next point is the battery, which powers the electric motors that results in transmission of electrical energy into kinetic energy. Next comes the control unit. As in case of electric vehicle, here also the control or power control unit is the power electronic system, while this operates to control the transmission of power from the IC engine and the electric motor, while the battery operates to power the electric motor in generating mechanical energy onto the wheels, while the control unit controls or magnifies the requirement of power on which the vehicle should run at what particular capacity. While the last one is regenerative braking system. The regenerative braking system runs on the concept of the power adaptation or utilization while the vehicle is under motion. So when the vehicle is under motion, the obvious fact of applying the brake onto the wheels results in loss of kinetic energy in the wheel wherein it is under motion. So regenerative braking system falls in a category which operates on utilizing the kinetic energy which is available or which might get lost during the application of brake and converting that kinetic energy into electrical energy and supply that electrical energy to recharge the batteries, wherein the batteries further supply electrical energy onto the electric motor, making it as a closed loop system. So that is how the regenerative braking system operates. Along with these components might be the thermal system, might be the transmission, will always be the part and participle of this particular electric vehicle or hybrid electric vehicle, but the operation condition differs. The only reason is that here it operates with both internal combustion engine and the electric vehicle platform. There are certain advantages and limitations obviously once these type of introduction of automobiles are there in the market. So one among the major advantages of this category is that it leads to higher mileage because the vehicle adopts the utilization of battery power in the beginning, and in the long run it makes use of the power supplied from the internal combustion engines. That results in giving the better mileage in comparison to that of normally fuel run engines. Seconds fall with the eco-friendly category, obviously because of lesser emissions in comparison to that of normal fuel powered engines because of the adaptation of both type of categories in which the propulsion is required. Next is cheaper cost per mile. Obviously when the mileage of the vehicle seems to be higher, the investment on fuel or on the battery recharging system leads to lesser amount of expense over the cost included in the mile transfer of the vehicle. Next comes the less regular maintenance, means to say that the normal fuel powered engines should run at a different category wherein the operation is focused on its maintenance for about 5,000 kilometer range for a petrol vehicle and 10,000 kilometer range for a diesel vehicle, whereas here it is a mixture. We have electric vehicles that runs for a plenty of miles greater than what fuel wherein we are what the normally fuel powered engines would give. Hence, in comparison with the normal regulatory fuel based engines that has to be taken into maintenance for 5,000 or 10,000 as such, here it goes with regular maintenance required because it operates in both the condition, leading to lesser utilization of IC engines compared to that of the normal fuel powered or normal IC engine vehicle. But that doesn't mean there are no limitations. We have limitations as well for hybrid electric vehicles. The first one being the same, higher purchase cost. Next being higher insurance cost. This seems to be the fascinating term now. Why? Because looking at the capacity at which the vehicle runs on both IC engines and the electric vehicle platform that is run by electric motor, if there is any delay in controlling the transmission between IC engine and the motor which is supplied with battery resource, there might be a chance of malfunctioning of power transmission that leads to huge amount of disasters. Hence, there is a requirement for higher insurance cost for this. That doesn't mean the vehicle is not safe, but it is to ensure the vehicle is insured for a larger amount so that whatever may be the disturbances that might have happened on both the platforms, that is the IC engine platform and the electrical vehicle, both are covered under the insured platform. Next comes the battery replacement, which is again expensive in its nature. Obvious fact of the example what we taken in case of electric vehicles, while the performance seems to be very moderate because it operates on both the conditions, and the performance of EV as well as the performance of IC engine is to be taken into account. Hence we categorize that under not better performer in the market but under moderate performer in the market. So this is about hybrid electric vehicles for your reference.